Right now, in a lab somewhere, a salamander is growing a brand new leg. Not a stump, not a scar. A perfect leg. Bone, muscle, nerve, skin. Good as new. Meanwhile, you can't reliably regrow the tip of a finger. Go. And yet, here's the strange part. Before you were born, a fetus can heal a wound and leave no scar at all. None. Same species, same body, at different moments in its life. 3 completely different outcomes. A salamander rebuilds. A fetus regenerates. An adult scars. So what changed? And what does it tell us about how fast and how well your body can actually repair itself? Because everyone wants to heal faster. The athlete with a torn tendon, your grandmother's hip, that cut on your hand that just won't close. We tend to treat healing like it's automatic. You get hurt, you wait, it fixes itself. But healing isn't a single event. It's a program, a sequence. And like any program, it has a speed setting. The question is, what controls that setting? And can you actually move it? Start with what healing actually is. When you're injured, your body runs 4 overlapping phases. First, it stops the bleeding. Then it sends in the cleanup and defense crews. Then it rebuilds tissue. And finally, over weeks or months, it remodels that tissue to make it stronger. Every one of those phases can run fast or slow. And a lot of ordinary things move the dial. In 1962, a British zoologist named George Winter noticed something that sounds almost too simple. He found that a wound kept in a moist, covered environment healed dramatically faster than one left to dry out and scab over. Just the environment, nothing injected, nothing high-tech, and it roughly doubled the speed of the surface healing. It was so counterintuitive that it took years for medicine to accept it. For centuries, we'd been told to let a wound breathe and dry out. Winter showed the opposite, and it quietly rewrote wound care. The lesson underneath it is the real point. Healing speed is not fixed. It responds to conditions. So, what are those conditions? What actually decides how fast you heal? The first is blood supply. Your repair crews travel by blood. Blood carries oxygen, nutrients, and the cells that do the rebuilding. Choke off the blood supply, and healing crawls, or stops completely. That's why smokers heal slower. Why diabetics can develop wounds that never close. Why circulation is everything. The second is nutrition. Your body literally cannot build tissue out of nothing. It needs protein for the structure, vitamin C to weave collagen, zinc and iron to run the machinery. Sailors with scurvy didn't just get sick. Old wounds, long healed, would split back open. Because without vitamin C, they couldn't hold their own tissue together. The third is one most people never connect to healing at all. Sleep. Your growth hormone, one of the main drivers of cellular repair, surges during deep sleep. Sleep badly, and you're literally turning down the repair signal every single night. And then there's age. As you get older, every one of these slows. Thinner blood supply, slower cell turnover, a repair crew that shows up late. So already, before any peptide, any drug, any hype, you have a dashboard of dials. Blood, food, sleep, time. But none of that explains the salamander or the scarless fetus. For that, we have to look at the strangest lever of all. Here's a question that sounds obvious until you actually sit with it. Why do you scar at all? A scar isn't the original tissue. It's a patch. It's weaker. It doesn't sweat. It doesn't grow hair. It doesn't fully work. So why doesn't your body just rebuild the real thing? The way it clearly knows how to, because it once did. In the 1980s, a fetal surgeon named Michael Harrison was doing something that sounds impossible, operating on babies while they were still in the womb. And when those babies were born, the surgeons noticed something haunting. There were no scars. The incisions had healed as if they'd never happened. A young researcher named Michael Longacre chased that observation into the lab. And, in parallel, in the United Kingdom, a cell biologist named Paul Martin was finding the same thing in mice. Martin pinpointed it precisely. Wound a mouse embryo early enough, and it heals perfectly. No scar. But past a specific day of development, embryonic day 14, that ability switches off. From then on, it scars, like the rest of us. So the capacity to heal flawlessly isn't something we lack. It's something we lose. Which raises the real mystery. What flips the switch? The answer is your immune system. Specifically, inflammation. When the fetus heals, its inflammatory response is muted, quiet, almost gentle. When you heal, it is loud, fast, and aggressive. And that same pattern shows up in the salamander. When an axolotl loses a limb, cells at the wound do something your cells refuse to do. They de-differentiate. They roll back to a younger, more flexible state and form a blob of rebuild-capable cells called a blastema. From that blastema, a whole new limb grows. But here's the finding that ties the entire story together. In a study around 2013, researchers depleted the immune cells, called macrophages, in axolotls right after amputation, and regeneration failed completely. No blastema, no new limb. So it's not that inflammation is bad. Without it, even the salamander can't rebuild. It's that inflammation is a dial, and the setting matters enormously. Too little, and there's no signal to start the work. Too much, too fast, and your body slams the wound shut with scar tissue instead of patiently rebuilding. And that is the trade-off evolution made for you. Your adult immune system is powerful and quick, because for most of human history, an open wound meant infection. An infection meant death. So your body chose speed and safety over perfection. Seal the breach now. Patch it with scar. Survive. The salamander lives in water, heals slowly, and can afford to rebuild. You are built to slam the door and move on. The scar isn't a bug. It's the price of a fast, infection-proof repair. So what does all of this mean for you, standing here with a body that scars? First, the practical part. The dials you actually control are real. Sleep protects your repair signal. Protein, vitamin C, and zinc give your body the raw materials. Blood flow, staying active, not smoking, keeps the supply line open. Managing your blood sugar keeps the crews working. And keeping a wound clean and covered, not dried out, is George Winter's 60-year-old lesson. Still true. That's not exciting, but it's real. And it works. And now we can finally close the loop on those two famous peptides. Because if you've heard the hype around BPC-157 or TB-500, this is the machine they're trying to tune. Remember what they actually do. They don't build tissue themselves. They're coordinators. They nudge the exact levers this whole story is about. Encouraging new blood vessels so the supply line grows. Calming and organizing inflammation so the dial sits closer to that patient fetal setting. Calling repair cells to the scene. Suddenly the obsession makes sense, doesn't it? They're not promising a new limb. They're promising to move the healing speed dial a few notches in your favor. But now, you also understand why the science is so unsettled, because that dial is dangerous. Your body throttles inflammation and blood vessel growth on purpose. Push them too hard, in the wrong place, and the same signals that heal a tendon could feed something you very much don't want fed. That's not fear-mongering. That's just respect for a system that took millions of years to balance. Promise is not proof, but at least now you can see exactly what's being promised, and exactly why the promise is so hard to keep. Which leaves one last uncomfortable thought. Inflammation, it turns out, is the master dial. Turn it up, and you heal fast but scar. Keep it balanced, and you rebuild. But what happens when that dial gets stuck on all the time? When the healing fire that's supposed to flare and fade instead just quietly smolders for years, everywhere in your body at once? That's not healing anymore. That's something scientists now think sits underneath aging itself. They've even given it a name, and that is a story for next time. Thanks for watching Brainstorm Bob. If this made you think, hit subscribe for more curiosity, ideas, and real answers. See you in the next one.